गाइस, कैसे हो आप सभी। उम्मीद करता हूँ सब लोग मस्त रहोगे, मजे में रहोगे और बहुत मेहनत करते रहोगे। सो या आई वेलकम you guys onto the second video of the custom chat gpt or make your own chat gpt video series, wherein we are going to build a custom chat gpt based on the knowledge base that we are having. So particularly in this video, what we are going to do is we'll dive deeper into the entire tech stack that we are going to use. We are going to explore what is LangChain. We are going to explore how we can use Google Antigravity. Yes, we are going to ditch VS Code for this particular series, and we'll go to using Google Antigravity to understand how agentic based IDEs work. And we'll also start the project in this video. So without any further delay, let's get into the video. So right now over here, we have anti-gravity present. So for the entire project series, we are going to use Google anti-gravity because it is basically agentic based IDE that has come across. So let's get into understanding what Google anti-gravity is more. So what it is, it's basically a next gen IDE as said by Google, and it is a agentic development platform which is evolving into an agentic first era, meaning it's a completely an AI IDE by core. And since I've been using IDE a lot, I have been using the Google Anti-Gravity a lot for my major of my projects. I particularly think it's completely agentic first because everything is agent based. Okay, so it has agent right from your editor to the terminal to the browser itself. So you can go and explore the page if you want, and for now I have downloaded it, but if you currently it's only available for Mac, so you can go and download it. If you don't have Mac, you can obviously go for VS Code or any other favorite IDE that you want. So in this video, we are going to understand how is the workflow happening. Okay, this is I think the earlier videos drawing. Okay, so let me just first go to Obsidian to show you how the things work. So the first high level architecture that looks like is like this. The user first pushes the .md file into a dedicated folder. Currently, the folder that we will be using would be a slash knowledge based folder, and the user will create the files in and particularly for now we will be using the markdown file format. So the user will push the files into the knowledge folder, which will be a .md file, and then it will be chunked and ingested, meaning we will be converting the entire contents of the file into smaller chunks. Okay, so let's get into understanding how we will be using the chunking part. Okay, so for that what we are going to use is LangChain text splitters. Okay, so what are text splitters by LangChain? So it's basically, it helps to break the large docs into smaller chunks that will be retrievable individually and will fit within the model context of the window limit. So we will be using the recursive text splitter for this particular project and for this particular task. And for the front end and the API creation, we will be using Next.js. So let's get started. Let's start by creating a basic Next.js application. I'll go to Google Antigravity. I'll open the terminal. No, I don't want to update my ZSH, and I'll just paste this, and I'll create the name as second brain YT. Okay. So yes, start proceeding with the application, and I'll just put it to a full screen. Now, what are the things that are happening here? Yes, use the default recommendations. It's creating the entire application for us right now. So let's wait until the application is created. Now that our application is created, we'll just go into that folder, and I'll be giving you guys a package.json which consists of all the necessary dependencies that we will be using. So rather than installing everything at once, I'll just copy it and paste it here. So let's get into one by one on what are the dependencies. These are the AI SDK for Google that we'll be using for getting the Google generative AI to connect with the RAG application and give us the response. We'll be using the LangChain community, text splitter. We don't need the Prisma right now. These are the React syntax highlighter, which will help us to give the code which is from the response and highlight it for the better user experience. Then we'll be using AI, which is the Vercel AI SDK. We also will be using ChromaDB, which acts as a vector store to store all the documents into a vector format. And these are some of the other dependencies that we need. So now that we have our dependencies, we'll just do npm install so that all our dependencies are installed. So now what we'll do is we'll go inside our application and create a folder with the name lib. Okay, and it will consist of all the necessary libraries that we need, and we will create a hook with the name chunk and ingest.ts. Okay, this basically will act as a hook wherein whenever the user submits a file, this file will be chunked and then ingested into the ChromaDB. Now, ingested meaning it will store the contents into the ChromaDB. So let's get into the UI and let's go and configure the ChromaDB here. Chroma, not this Chroma store. We'll go into and we'll just sign up. If you have an account, it's better you can just log in over there. We'll sign up with Coding Adda's account. Yes. And the database name. Let's create a database name as second brain. Okay. And we'll have the AWS US East one. Okay. Now we have to configure the Chroma SDK. Okay. So now what we'll do is, since we are using the Next.js framework, we will click here and do the Next.js framework. And what we'll do is create an API key and copy the code. Okay. Now that we have copied the code, we will go into Antigravity and paste the env files over here. Okay. So these are the API keys, the tenant name, and the Chroma database. So now that we have our environment variable set up, our next task is to now create the library which will help us chunk and ingest into the ChromaDB. So for now, we will just be ingesting it. We will not be chunking it for now. So before that, we will have to create a Chroma client which will act as a library to connect the Chroma database to our project. So we'll just create a file with the name chroma client.ts, wherein first what we'll do is we will import cloud client from ChromaDB, and then next we'll import .env from .env, since we are using .env. When I say Antigravity acts as an agentic first platform, this is how it acts. Since we have just imported the two necessary packages, now agent based system gives us, okay, since now you have imported the two main packages that you need, okay, you don't have to do much work. We will just have you import and config the .env and then just create a basic Chroma client. So for now, what we'll do is we will store the API key into a variable. So we'll have process.env.chroma API key and make it necessary. Then we have the tenant TNNT. This will be Chroma tenant, and we'll have const database as Chroma database. So we'll just go here, and I think everything is kept as the same. Okay. Now, obviously, to do the checking for the API keys and the tenant, if no API key or if no tenant or if no database, give us an error, missing environment variables. Okay. After this, we'll have export const chroma, which will be a new chroma client, and we'll just remove this. We'll just have API key, then the tenant and the database. Okay. So the three things that we have configured, we'll just export it. And then we'll also export an async function, which will be get or create collection, which will have a variable as name, which will be of the format of string, and then it will create a collection in Chroma with the name as name. Okay, so this is the first thing that we do. We created a Chroma client, we got the API key, tenant, and the database from the env, and then we exported the chroma, and then also a function which will help us create or get the chroma client. Okay, so this thing is done. Very good. So the next step here is to now start creating the library. So we will first have a use server here, use server, then import recursive character text splitter from LangChain text splitters. We don't need to get it from core. So recursive character text splitter from LangChain text splitters. So let us first go on to LangChain and understand what it is. Recursive text splitter. So, and since here we are using TypeScript, we'll have to go here. Yeah. So text is naturally organized into hierarchical units such as paragraphs, sentences, and words. And we can leverage the inherent structure to inform our splitting strategy, creating split that maintain natural language flow, maintain semantic coherence within the split. So this basically helps to attempt to keep the larger units intact. So it's basically recursively splitting the text that we are giving. So we'll first import this, and also we'll import get or create collection. And now we'll export an async function. Let's say we'll keep the name as ingest text into chroma. Okay. And for now, we will not be ingesting it into chroma. We will just be understanding how we are getting the input and how it is converted into chunks. So the first name would be the collection name meaning the collection name that we are keeping into the chroma. The first name is collection string. Next would be the file path, because obviously the file would be the main important thing that will be converted into chunks and then into embeddings. Then the text, obviously also in the format of string, and there would be some other things such as metadata, which will be in the form of a record, and the first thing would be string and second type would be any, and then an object. Okay. After that, what we'll do, we'll have a variable called splitter, which will help us create the chunks out of the text. So now what we do is we have a new object created out of recursive text splitter, character text splitter, wherein there are two options that we have. One is the chunk size and other is the chunk overlap. What are they? Chunk size is basically the maximum number of tokens or characters a single text segment or a single chunk will contain. Basically, it helps to determine the density of information in each vector embedding. And chunk overlap is basically the number of tokens that are repeated between the end of one chunk and the beginning of next. This basically helps to ensure that the information at the edge of the chunks is the same, meaning there is no information lost between them while chunking. Okay, so we created a splitter. Now what we do is const chunks equal to await splitter dot split text. Okay, the text that we get, we will just split it, and then we'll call for the collection. So const collection equal to await get or create collection, which the collection name would be the database name. Okay, so this is how we are adding or creating the chunks. Next step for us would be now to create the function or logic to save the chunks to ChromaDB. Okay. Moving before that, next thing that we will be implementing here is the API. Okay. So let's go into app and we'll create a folder. We'll create a folder with the name API, and then the API would be ingest, and then the name would be route.ts. So whenever we are using Next.js, we don't have to create a different folder just like we do for React, wherein we create a server folder or an initialize Express.js server or a Node.js server and then connect it to the React application. Whereas in Next.js, what we have is internally the APIs are built. So you don't have to go over there and then complete it. So we will have the ingest as the API. So there are a couple of things that we will be importing. First would be import crypto from crypto, then next request from next server, ingest text into Chroma, and then get or create collection. Okay, we'll also export the runtime as Node.js. Okay, and now let's configure the Chroma API key. Chroma const API key equal to process dot env dot chroma underscore API key. We don't need the API base and API version. We'll only need the Chroma API key. Okay. So now the first thing that we will be doing is to hash the content. Okay. So function hash content, wherein the first thing would be a text in the form of a string, and we will return crypto.hash SHA using the SHA 256 algorithm and update the text and digest it in the form of hex. So what is digest here? Calculates the digest of all data paths to be hashed. If the encoding is provided, a string will be returned. Otherwise, a buffer will be returned. So the first thing that we did was to hash the content. Now let's create the function export async function as a post. The thing that will be passed would be a request, and it will be in the form of next request. And next, then we'll have the file path const file path, and the content equal to await request.json. Okay, obviously now to check if the file path exists or not, if the file path exists or if the content it does not exist, return a new response saying missing file path or content with a status of 400. Now you see, our work as a developer becomes so easy when agent itself gives you what are the next steps to perform. So now let's create the collection const collection equal to await get or create collection, and keep the collection name as second brain. Okay, and then we'll do the hashing of the file hash equal to hash content with the file path, not the file path, with the content. Okay, now let's try and understand how our file is working, or how our project till now is working. So now let's actually get into how the Agentic IDE works. Now that we have our ingest route ready and the chunk and ingest library ready, now what we'll give to the agent framework here is I am creating a custom chat GPT application, not application, wherein the files from knowledge slash in the form of MD would be converted, would be I'll change it to would be converted into chunks and then ingested into ChromaDB. For now, I have the API and the lib function ready. Please create a dummy.md file and test it to check if everything is working as expected. Okay, so I told the application only to create a function and then test to see if everything is working as expected. What I'll do is, for now I'll just create a folder inside second brain and I'll keep the name as knowledge. Okay, and I think .env is outside, I keep it inside. Okay, I'm creating an application wherein the files from knowledge.md would be converted into chunks and ingested to ChromaDB. For now I have the API and lib function ready. Please create a dummy MD file and test to check everything is working as expected. Do not insert anything to ChromaDB. Okay, So I have just given it the given single prompt, and the model that I'm using here is Claude Opus 4.5, the thinking one. And there are two modes here. One is a planning mode and one is a fast mode. Planning mode, basically agent will plan all the tasks that you need, and it will ask for your approval to move ahead with it. Whereas in the fast mode, agent will directly execute the task. Okay, so let's see. The user wants me to create a dummy MD file inside knowledge folder, test the existing API, and not insert anything to ChromaDB. What it did, it analyzed the files, chunk and ingest, and the route. There is some error that it faced. I see the knowledge is not a directory yet. Okay, it is creating a directory. Okay, mkdir file knowledge exists. Where does it exist? I think it deleted by it. Okay, I had the folder name. I had given it a file name. I'll just delete. Okay, it is automatically going here and deleting it. So RM knowledge, it deleted the knowledge folder, deleted the knowledge file. So now as we see, it says the file is not displayed in the text editor because it is a directory. Okay, it is right by its logic. So there are two nodes that is creating, sample nodes.md, like introduction to machine learning, key concepts, everything, and test chunking.ts. This is basically creating a test script to verify the chunking functionality, to test the chunking functionality. This script tests the recursive text splitter without inserting into ChromaDB. Okay, I'll just tell, but I want to use the slash route, use the ingest API to test it. Do not create uh, do not create any other files here. If needed, make the changes in the ingest route itself. Okay, I'll just cancel this and add the comment over here. I'll not accept this, I'll reject this. I'll have the notes accepted. Okay, and I told please use the ingest API only rather than creating a new file to test it. So it will go and modify the ingest API. Okay, there are some changes that it did. If the test mode is true, only perform chunking and return results without inserting into ChromaDB. And then if it is false, then it will insert it. Okay, I'll accept the changes. Now what it is showing is, let me test the API using curl with a sample markdown file. Okay, accept it. Failed to connect to localhost because the server is not running. Okay, let me do one thing. Let it only run the server. I'll use npm run dev. Now it's running, and now it will parallelly go and use the curl command to execute the script. So now that it asked for testing the API, I gave up the command. Okay, run it. So the next thing that it did is right here in front of you. So if you can see here, the index is 0, the length is 742, and this is the preview. This is the full content of the file. Then the length is 1, index is 1, length is 904. It's like it has created 3 indexes with a given certain length, and the test was successful. The chunking functionality is working correctly, and the markdown file with 2540 characters was split into 3 chunks. So now we can say that our APIs are working fine, wherein we are getting the file from the knowledge folder and then it is converted into chunks. So now that we have our backend API ready to get the file from the knowledge folder and then convert it into chunks, what we are going to do in the next video is to then convert the chunks into an embedding and then storing the embedding into the ChromaDB database. But here's a catch. We won't be using the traditional way to convert the file contents into embedding. Rather, we will be using GitHub Actions. It is a completely new way wherein automations will be introduced into the projects. And yeah, this is a pretty different approach that usually goes with it. So yeah, I hope you guys understood what are the basis of chunking, what are the recursive text splitters, how Google Antigravity works, how the agent-based IDE works. So yeah, see you guys in the next one. Until then, bye-bye.